Today's class, we are going to discuss rectangular Cartesian system. Basically, we are going to discuss about two-dimensional planes and how do we locate any particular point wherever it is on 2D planes. So for doing that, first of all, we'll have to divide the plane in two halves. First, let's say we have a paper and then we have to draw a line in between the paper and another line just perpendicular to it in between the paper. So this is a plane. These axes intersect at a single point, which is known as origin. And this particular origin will be considered for the as a reference point for locating any point. And these two lines that we just drawn will be known as axis. This will be known as y-axis. This will be known as x-axis. These both lines are perpendicular. And this point, as I called it, as I said, it's zero origin. So 1 unit away, 2 unit away, 3 unit away. Similarly, -1, -2, -3. This may be known as x dash or minus of x. This is plus of y, this is plus of x. So +1, +2, +3, like this. Similarly, -1, -2, minus of 3. Y dash or minus of y, part of x. Now, how particularly we are going to locate any point on this plane? We are going to, first let me, yes. Now, there's any point, anywhere. There's any point, anywhere. Then just what we are going to do, we are going to calculate the distance between the point, let's say this point as P, the distance of this point from the x-axis and the y-axis. Now we know x and y-axis are straight lines. So we are going to calculate the shortest distance. We know perpendicular distance is the shortest distance between a line and a point. So discussing about the distance between x-axis and y-axis, this is that length. Okay, and this is perpendicular to the axis. Discussing about the distance between the point and y-axis is this distance. Okay, let's call this distance as this is going in like horizontal direction. Let's call this as small x. And this distance is going in the perpendicular in the vertical direction as y. So if this is x distance, we may call this much distance as also x. And this much distance as y. So this is a y point because it's from 0 away. So it's y units away, and this is also x units away. And this point is somewhat x away from y-axis. So we'll call this that its coordinate on the x-axis is small x. Its coordinate on the y-axis is small y. And this, ladies and gentlemen, this is the point on a Cartesian plane. So we have discussed about what's a 2D plane. We have discussed about axis. And mind it, the difference between axis, that this is used for a single axis, and axis, this is a plural word used for more than one axis. Point, we have just discussed about a point, how to locate that point. Now let's discuss about quadrants. As we see that this is plus x, this is plus of y, this is minus of x, this is minus of y. So whichever point lying here in between x, o, y in this particular plane, this is known as the first quadrant. And in first quadrant, every point will have a positive x and a positive y. So the sign convention for the first quadrant becomes positive x and positive y. For the second quadrant, there will be positive y's. Second quadrant is this. For the second quadrant, there will be positive y's and negative is x. So negative x and positive y. Second quadrant. Third quadrant, there will be negative x and negative y. I'm discussing about this. Negative x and negative y. Fourth quadrant, this one, positive x and negative y. So these are some to remember. Coming to the next, as we have talked earlier, if there is any point x distance away from the origin. So this is like we can call this point, and its point will be that it is x distance away from the y-axis. Okay. But this is lying on the x-axis. So its y-coordinate will be 0 because its distance from the x-axis is 0. This is something weird to understand, that the x-coordinate is also known as abscissa, is the perpendicular distance of a point from y-axis and vice versa for y. The y-coordinate, or known as ordinate, y-coordinate or known as ordinate is the perpendicular distance of a point from x-axis. This is the basic. Now coming to the point that we were discussing here, the coordinate of any point on x-axis are of the form x0, because any point on the x-axis will be lying on the x-axis. So the distance between the x-axis and the point is 0. Y-coordinate is going to become 0. When we are discussing about any point that is lying on the y-axis, so the distance between y-axis and the point is 0. So that's why the x-coordinate is 0. I hope that's clear. Next point, if the x-coordinate or abscissa of a point is 0, it would mean it's just the otherwise. No? It's just the otherwise of this point. That if the x-coordinate or abscissa of an point is 0, so it means that the distance between the y-axis and the point is 0. So it means the point is lying on the y-axis. And if y-coordinate or ordinate is 0, then the point is lying on the x-axis. As simple as that. Moving ahead, now we will discuss about the distance between 2 points. So before referring to this text, let's become Atmanirbhar and Okay, I hope that's perpendicular. Anyways, so now let's discuss about what we were discussing earlier, distance. So as this is origin, and let's call this point, let's say that we need to find out the distance between origin and the point. The point is x, y. So this distance is going to become y, and the perpendicular distance between this is y-axis, this is x-axis. So y-axis and the point is x-axis, is x. So this distance will also be x. Okay, we know this is a perpendicular. Using Pythagoras theorem, this comes out as square root of x square plus y square. The distance between OP comes out as square root of x square plus y square. Okay, fine. But what about the distance between 2 points? Here we were discussing about the distance between a point and the origin. And whenever we mostly discuss about, so uh, this will be in relation to some other point. Okay, so if that is the case, we have to use this formula. Distance between 2 points. Let's call this A point as x1 y1 and B point as x2 y2. Square root of x2 minus x1 plus y2 minus y. Again, the root is Pythagoras theorem here. So this is very important formula. And if O is the origin, that's the case we have discussed, then the distance formula will be square root of x square plus y square. If we have, without further ado, let's jump on to the questions. Here in the question, we are given the points and are the vertices. Okay, so we have 3 points and we have to find out that these 3 points are lying and making which kind of triangle. Are they making an isosceles triangle or an equilateral triangle or a right angle triangle? An isosceles triangle means a triangle having two equal sides. Iso means same. And an equilateral triangle, as it is having three equal sides, all three sides are equal. A right angle triangle is a triangle whose sides will be following Pythagoras theorem. Okay, so let's jump on to this question. So let's name these points as A, B, and C and find out the distance between the all three sides. First, let's find out the distance between A, B. It is 0, 0, so 3 minus 0 whole square plus root 3 minus 0 whole square. 3 square is 9, root 3 square is 3. Square root of 12 is our answer. Discussing about the distance of BC, 3 minus 3, 0 whole square plus root 3 minus of minus root 3 plus root 3. So it becomes 2 root 3 whole root. Oh, sorry. 2 root 3 whole square and then square root. So square root cancels this. This comes out as 2 root 3. And if you like further solve 12, where 12 can be written as 4 into 3. Square root of 4 is 2 root 3. Okay. So AB and BC are same. Let's find out AC. So 3 minus 0 whole square plus minus of root 3 minus 0 whole square. This comes out in 9 plus 3, which is the same square root of 12 at 2 root 3. So as we know, all three sides are equal, and that is the case of an equilateral triangle. That is the case of an equilateral triangle. I hope that's clear. Let's move on to the next example. Yes, here we can see in the solution. Distance formulas application simply. Example number 2. There are 3 points given. In one of the point, there is a variable. Be 3 points such that a condition is given. EB is equals to BC. We have to find out the value of the given variable X. Okay, fine. So, and we need, there can be two possible values of X as per the options. Okay, we'll keep that thing in our mind. So, AB 6 minus 1 whole square plus minus 1 minus 3 whole square is equals to BC. So 1 minus of x whole square plus 3 minus of 8 whole square. Square root cancels both sides. 6 minus 1 is 5. 5 whole square is 25 plus minus 1 minus 3 becomes minus 4. Minus 4 whole square is 16. This equals to 1 minus x whole square, 1 square plus x square minus of 2x plus 3 minus 8 minus 5 whole square is plus 25. Plus 25 cancels on both sides. This comes out as x square minus 2x plus 1 minus 16 becomes minus of 15. Okay, so we have a quadratic equation. So we can find out two values of x. Here we need to find two such values of x for which the multiplication is minus 15 and the sum is minus of 2x. And sorry, so the sum is 2 plus 2. Remember, alpha plus beta is minus of b by a. And alpha beta is c by a. Okay, so c by a is minus of 15 and minus of b by a is 2. So the sum has to be plus 2 and thus product has to be minus 15. So definitely there will be two numbers having opposite signs, and the negative number will be the smaller number. So 5 and 3 can be our answer, right? 5 and minus of 3. The sum is plus 2 and the product is minus 15. So this is our answer. Plus 5 and minus of 3. Option number A should be the correct answer. Please observe. Yes, it is the correct one. Please observe. Let's move ahead. Now comes section formula. So as it is mentioned here, let O be the origin. Okay. OX and OY are the axis then. Okay. Let there is a point and there is another point, be the given points. Okay. So here is our Cartesian plane. I tried my best to make it perpendicular. And there are 2 points given, A and B. In first scenario, we are going to consider, let's first write A point is having x1 and y1 as coordinates, and B point is x2 and y2 as coordinates. That right here. Okay. So these are the 2 points. They are making a straight line. So we join them. And on this straight line, there exists a point. Let's call this point as C. And this C has also has coordinates x and y. It will be given to us sometimes that this C point is dividing AB length, AB side in some ratio. In what ratio? Like the ratio will be AC divided by CB. And this ratio will be given like M1 is to M2. So AC is M1 is to M2. Now we are supposed to derive a relationship between, we are supposed to find out the coordinates of x and y using m1, m2, x1, x2, and we are supposed to find out y coordinate by using m1, y1, m2, y2. So the formula is, so here the C point is dividing internally and making sections. So the formula for x coordinate is m1 x2 m1 x2 plus m2 x1, okay, crisscross, divided by m1 plus m2. M2 x1 plus m1 x2 divided by m1 plus m2. For y coordinate, same pattern, m1 y2 plus m2 y1 divided by m1 plus m2. This is the section formula for internal division of any point between two given points. Okay, this is important for you to take a note. Sometimes candidates do get confused here. It may also happen. Now I'm not like drawing the Cartesian plane again. It may also happen that there are 2 points, okay, making a straight line. These are 2 points. Now comes a point, okay, and that point is there on the same straight line, but on the extended one, on the extended part. Okay, let me redraw it. But on the extended part. There is a point lying here C. A point is coordinate is xy, y1, x2, y2. And the ratio will be given like AC divided by BC, the extended part. EC divided by BC, and that will be given as M1 by M2. Okay. Remember, students get often confused here about the ratio. M1 and M2. Okay. This is known as the external division. And the formula for this, point C having coordinates x and y. X, same formula, M1, X2, M2, X1, but with the negative sign. M1 Y2 minus M2 Y1. Very easy to remember. Please reread. Let's now solve some questions. So this is the formula for external division. Formula for internal division, have a plus sign. First question. If A point and B point are 2 points, then find coordinates of the point on line joining AB, dividing it in, okay, the ratio 5 is to 1. Okay, so there is a point, there is a line AB, and the point is on the line joining AB, and it is dividing it externally, so the point will lie somewhat ahead in 5 is to 1 ratio. The coordinates of A is 0, 0. What B is 12, 12, 0. For C is what we need to find out. We know the formula of X. M1, X2, that is 12 here, minus M2, that is 1 here, into X1, that is 0 here, upon M1 minus M2, 5 minus. For Y, M1, Y2, which is 0, minus M1, sorry, M2, that is Y, that is 1, into Y2, that is 0, upon 5 minus. So simple, that becomes 0 by 4, that becomes 0, and X comes out as 60 upon 4, which is 50. The point is 15, 0. Option number C is our correct answer. That is our correct answer. Going to the next example. Find the coordinates of point on the line joining the points P and Q, that is twice as far as P as Q. Okay, let's reread the question. Find the coordinates of point on the line joining the points P and Q. Okay, P and Q. That is twice as far as P from Q. Okay, so it may happen both. Like if there's a line PQ, then there may be a situation that let's consider this point as X. So there may be a situation that PX is maybe double than X cube, or it may also happen on external division that P and Q are here and X is here. It may also happen that PX is here equals to 2QX. This may also happen. So both internal and external division can be possible. We are just going to solve the questions. Solve the question now. Okay. So what's the difference? For x, we are going to consider m1, x2 plus and minus both. Why? Because we'll solve the question in one go. Because we have to find out for internal and external division as well. And whichever the formula, the question's option will match, we'll take that option. m1 y2 plus and minus 2y1 divided by m1, because we have to solve for both of the vertices, vertex for the both of the divisions. Apt. Making space. Now let's solve for the x. m1 is, as we got to know, that this is twice of 1. This is twice of 1. Okay, so m1 is 2, m2 is 1. 2 into x2. x2 is minus of 2 plus minus m2, which is 1 into x1, that is 3, divided by 2 plus minus 1. For y, m1 is 2 only, y2 is 5. Y, this is the second point now. So y2 is 5 plus minus m2, which is 1, into y1, which is minus of 5, divided by 2 plus minus. Solving this will give us as minus 4 plus minus 3. So let's do it here only. Modification, this is minus 4. This is simply 3. This is 10, 2 into 5. Plus 1 minus 4, that becomes minus of 4. Now, how minus of 4 will be written here? The plus sign will be changed into minus. The minus sign will be changed into plus. Okay. So let's find out the both x values for x. First, considering the plus value. So minus 4 plus 3, minus 1 divided by 2 plus 1, that is 3. 2 plus 1, that is 3. Or considering the minus sign this time, the other sign, second case. Minus 4 minus 3, that is minus 7 divided by 2 minus 1, that is 1. Okay. So in the options, we do not see any minus 1 by 3. So we only have to consider the second case. So, okay. Why? Considering only the second case, 10 plus 4 becomes 14. 2 minus 1 becomes 1. So the point is minus 7 and 14. Minus 7 and 14. Option number A should be our correct answer. And let's check. Yes, it is the case. And look what they have done. They have to solve twice. We smartly just written plus minus simultaneously. Coming to the next. In this, there's a misprint. There's 4 here. We have to find the coordinates of the point which divides the line segment joining these 2 points internally or externally in the ratio 3:1. Yeah. So it's not given that the division is internal or external. We have to look for the points for both division and then match the result with the options. Okay. So x1, x2, sorry, x1, y1 and x2, y2, and this is m1, m2. Simply let's start with x. m1 into x2. Sorry, m1 is 3r. m1 is 3 into x2, that is -2, plus minus m2, that is 1, into x1, that is 5, divided by 3 plus minus y. m1 into y2 plus minus m2 into y1 divided by 3 plus minus. Usually candidates do a mistake that for while writing y2 or y1, they write x2 or x1. Okay? So that's a common mistake you have to avoid. -6 plus -5 divided by 3 plus minus 1. Y 18 plus minus of 2. So minus sign will change in the case 3 plus minus. Considering the first plus, let's say for the internal division, -6 plus 5 minus of 1 divided by 3 plus 1, that is 4. Or -6 minus 5 minus of 11 divided by 3 minus of 1, that is 2. For y, internal division 18 minus 2, 16 divided by 4, that becomes 4. Or 18 plus 2, 20 divided by 3 minus 1, 2, that becomes 10. Okay, so -1/4 is not there in any option. Let's rule out that possibility. Discussing about -11/2, it is also not there in the any option. So I guess we have done any mistake somewhere. Anyways, let's look for the y. Is there y with 4 value anywhere? No. Y is 10 somewhere. Okay. So y is 10. Y is 10. These two options are eliminated. Now let's check for +11 or -11. Let's recalculate the x. So m1, there is 3. x2 which is 6 here. Sorry, x2 is 9 here. So there's the mistake I have also done. I've written my y2 here. Sorry, y1 here in place of x2, which is 9 here. 3 into 9 becomes plus of 27. 27 plus 5 becomes 32. 32 divided by 4 becomes 8. Okay. And 27 minus of 5 becomes plus of 22, which will become plus of 11. So plus 11 and plus 10 are the coordinates, which gives us option number C as our correct. Please don't be prone to human errors. You have to practice a lot and you have to be careful while solving it so that you don't do the mistakes. And options will always help you to find out your mistake. And of course, if you practice more, you'll get experience, you'll get to know which silly mistakes that I am prone to, and then you'll be neglecting those. So we have discussed enough examples. Let's move on and let's now discuss that how we can find out the area of a triangle in two-dimensional Cartesian plane. Okay, so we just need one thing, that is the vertices. If we know the coordinates of all 3 vertices of a triangle, we'll be able to find out the area of a triangle. Let's look how. So our answer is correct. Okay. Area of a triangle. If the vertices of the triangle are given with us, the coordinates of the vertices of a triangle are given as A, B, C. Triangle A, B, C. Vertices are given. So simple area of triangle's formula is this. Half into determinant of x1, y1, 1. Like the third whole column is 1, 1, 1. And here then you will write the points. All the points. There's the pattern. Okay. And there are double. So this is for the determinant. And this is the modulus function to take the positive value only. Okay. The expression of the same is written above. X1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So here, simple pattern. If you would like to remember this formula, then remember it like how I did. I remember 23, 31, 12 for the y1, for the y's, and x1, x2, x3 are obvious. You can remember it in English also 23, 31, 12. 23, 31, 12. 23, 31, 12. Otherwise, this method is the best. There are some additional pointers given. If ABC be the sides of a triangle ABC, then the area of triangle can also be given by the Heron's formula. S is the semi-perimeter area. A plus B plus C divided by 2. If we have all the sides of a triangle, we can use this formula to find out the area of triangle. So let's now discuss an example. We'll do this later. Area of a triangle whose vertices are 3, 2, 11, 8, 8, 12. So there are 3 vertices given. So what we need is this area of triangle half into determinant 3 by 3, 1, 1, 1. First point here, second point, then the third. Simple. Half into 3 into 8 minus 12, minus of 2, 11 minus 8 plus 1. 11 into 12 becomes 132 minus 8 into 8, 64. Half 3 minus 8 minus 12 is minus 4, minus 4 into 3 minus of 12 11 minus 8 plus 3 plus 3 minus 6, plus 3 minus of 2 becomes plus of 6. Yes. No. Plus 3 into minus of 2, that will be minus 6. 132 minus 64, that comes out as plus 12 minus 4, 8. 12 minus 6, 6. Okay. 12 minus 6 is 6, 18. 12 plus 6 is 18 and minus sign into, so minus 12 minus 6 will minus be 18. 68 minus 18 is 50 divided by 2. That becomes our answer as 25 square units. Which is option number B. Let's check whether our calculation is correct or not. Yes, absolutely correct. Now let's discuss this point. Now 3 points will not be always making a triangle. Those 3 points can be on a single line also. And if those if 3 lines are existing on a same straight line, then we call those and we name those 3 points as collinear points. If 3 points are existing on a same straight line, then we call those 3 points as collinear. So if those 3 points are there on a straight line, so the kshetrafal, so the area in formed by those 3 points are zero, is basically zero because they are not forming any triangle. So if there is no triangle, the area is also zero. That is why we use the same formula for finding out the area of a triangle and we equate them as zero because area formed by three collinear area of a triangle which is even not formed, whose area will be zero definitely. So for collinear points, the area of triangle formed by them, which is not existing, which will be that will be zero. So half, if we bring 2 on the right hand side, it will get vanish, and the condition for collinearity of 3 points becomes this. Simple 1, 1, 1 points. The pattern is. If that is clear, let's move ahead for solving a question. This one. There are 3 points given, okay, and there are variables h and k. These 3 points are collinear, okay, so they will be following our condition, okay. The we need to find out 1 by h plus 1 by k. We need to find out sum of 1 by h and k. Okay, so we know the condition. The condition is points 1, 1, 1, h and 0, 0 and k. This is 0. Solving the determinant, 3 into 0 into 1, 0, minus of k, minus of 3 into h minus 0 plus 1 into hk minus 0 should be equal to 0. So that makes us 3 minus 3k minus 3h. Bringing the hk on the right hand side, this makes it minus of hk. Now multiply by minus on both of the sides, minus minus plus, minus minus plus, minus minus plus. Here we can observe a pattern. We can take 3 common. K plus h is equals to hk. Now let's bring the hk on the left hand side. 3 into k by hk plus h by hk is equals to 1. K cancels k, h cancels h. This becomes 3 into 1 by h plus 1 by k. 3 into 1 by h and 1 by k. Bringing the 3 on the left hand side, this comes out as 1 by 3. Answer becomes option number 8. Simple. Just following the omens, like Safar did, the alchemist. Just see, like, if whatever you have learned, that is of some relevance, and based on that only the question is going to form. So you know the condition, there will be questions made on that. Let's take one more example. In this example, it is given that the vertices of a triangle be AM1 square and 2AM1 and AM2 square to AM2 and AM3 square and 2AM3, then find the area of the triangle. Okay. And there are some options. One thing is to assume the values for M1, M2, and M3 and A, so that all the options will be giving us the different values. Or the other method is to just solve them using our conventional method. Okay, so let's solve them using the conventional method only. The vertices of the triangle as given, we have to find out the area. The formula for area of triangle is half into 1, 1, 1 into the points a m1 square and a 2a m1, a m2 square and 2a m2, a m3 square and 2a m3. We know indeterminate, we can take common from columns. So 2 is there, 2a is there in the second column everywhere. So we are going to take common 2a. And a is also common in the first column. Okay. So taking a common from the first column into 2a common from the second column divided by 2. What is left in the first column? m1 square, m2 square, m3 square, m1, m2, m3, 1, 1, 1. Now the determinant seems more shorted. 2 cancels 2, a cancels a into a becomes a square. Okay. This becomes a square. Okay. Now let's apply some operations. Operations, because we can look that m1 minus, if we like make 0 here and 0 here, then only 1 will be left in the column. That would be great for us to solve the determinant's value. So how we can do so? We can do so by subtracting the row number 2 from the row number first, and by subtracting the row number third from the row number 3. Let's do it. A square into row number 1 minus row number 2, m1 square minus m2 square, and m1 minus m2, 1 minus 1, that is 0. Row number 2 minus row number 3, m2 square minus m3 square, m2 minus m3, 1 minus 1, 0. And row number 3 is unchanged. Sorry. Here m3 is there. Now we can observe a pattern here. A square minus b square can be written as a plus b into a minus of b. So this may be written as m1 minus m2 into m1 plus m2. So basically my point is we can take m1 minus m2 common, because here 0. So 0 upon m1 minus m2 is 0. So let's go take common m1 minus m2 from the first row. And similarly, m2 minus m3 can be taken from the second row. Okay, multiplying m2 minus m3. Okay, done. So let's write what is left. So here m1 plus m2, here 1, here 0. m1, m2 plus m3, here 1, here 0. m3 whole square, m3 into 1. Okay. Now we are somewhat approaching questions, the options that are given to us. Somewhat we are close. Let's solve this further. Let's solve the determinant now, because it has become very simple. Let's solve the determinant using the third column. Why the third column? Because there is only one here, others are zero. So 0 into anything, 0. 0 into anything, 0. Plus 1 multiplied by m1 into m1 plus m2 into 1. So m1 plus m2 minus 1 into m2 plus m3. So m2 plus m3 minus m2 minus m3. That is a determinant. And also, okay, so a square into m1 minus m2 into m2 minus m3. And this has become 0 minus 0, okay, 0. This has become m2 minus m2 cancels. This has become m1 minus m3. Now let us match the options. A square, okay. So B option is eliminated. A square into m1 minus m2 and m1 plus m2. No. So there was, if we see in our result calculation, there were negative signs between m1, m2 and m2 everywhere. There were negative signs. कहाँ गया? Here. So option number A should be our correct answer. M1 minus M2, M2 minus M3, M3 minus M2. So option number A becomes our right answer. Let's proceed. Okay, our answer is correct. Area of quadrilateral. So basically, to find out the area of quadrilateral, we know there will be 4 points given. Okay. So, quadrilateral. So this is a coordinate. We know the coordinates of the 4 vertices will be given. So what you have to do is simply make 2 triangles out of it. Simply join these 2 points and find the area of the triangle ABC and the area of the triangle EDC and then add them. Simple. Area of triangle ABC and area of triangle EDC. Add them and that is the area of your card. As simple as that. There's an example. Let's solve it. The area of a quadrilateral whose vertices are these. We need to find out the area. Okay. So first let's find out the area of triangle ABC. 1, 1, 1. The first point, second point, third point. Plus the area of triangle. Which triangle? ABC. So this was APC. This was APC. Yeah. Now area of triangle ACD. So we are not going to consider the B point, only ACD. 1, 1, 1. 1, 1 is the first point, 7 minus 3 is the second point, 12, 2 is the third. Cool. Let's take half common from both of the uh, determinants. Let's hold the determinants now. 1 into 21 minus of minus 3 minus 1. 7 minus 7 plus 1 into 7 minus 3 minus 21 into 21 minus 7. 21 into 7. Okay, that becomes 147 plus 1 into minus of 3. Sorry, minus of 3, minus of 2, minus of 1 into 7 minus 12. 7 minus 12. Okay, I'm writing it correctly. 1 into 7 into 2, 14. 12 minus 3, minus 30, minus minus plus 36. Just we need to be very careful about the calculations. 21 plus 3 becomes 24. 7, 0. This becomes minus of 21. And we need to remember that this overall value has to be positive. This overall value has to be positive because that's the area of some triangle. Okay. 21 plus this becomes 8 and 68. Okay. Plus this has become minus of 5. This has become minus of 5 into minus 1. That's become plus 5. Okay. Plus 1436 becomes 50. Okay. So that is it. Now half. 24 minus 168 becomes 4. Okay. 16 minus 240. Okay, so that's it. That's positive. Why positive? Because it's an area of a triangle. Plus plus minus 5 plus 5 becomes 0. This becomes 60. Okay, is equals to that becomes 204 divided by 2. 150, 144 plus 60 becomes 204. That should become 102, which is not matching with our any options. So I'm very sure that we have done a mistake. Otherwise, there's a mistake in the solution. So have you taken the options correctly? Yes, yes, yes. Okay. 1 into minus of 3, minus of 2, minus of 1, 7, minus 12. Okay. Plus of 1, 14, plus 36. That's correct. Now moving ahead, 24. Okay, okay, okay. So 1 into minus of 3 minus 2, that is minus 5. Correct. 7 minus 12 is actually minus 5. Minus 5 minus 1 makes it plus 5. Plus 14 plus 36 is 50 only. Okay, that's 50. I have written here 60. 50. That becomes 194. 194 by 2 becomes 9, 7. 97 should be our answer, which is not matching with any of our options. Let us check why. Area of triangle ABC, area of triangle ABC. Okay, okay. We have done the same. Let's check it from here. Was our matrix correct? Yes, the matrix was correct. First matrix. Second one, second was incorrect. 7, 21, 12, 2. Okay, so they have done it incorrectly. See, they were finding out the area of triangle ABD. So points are given like A, B, C, D. What they are doing, they are first finding the area of triangle ABC. Okay, and then they are finding the area of triangle ABD. This. So basically they are adding. Let me show you. They are doing a big mistake. Okay. they are adding this triangle plus this triangle and this triangle again. Hana? So the angle, so this area is calculated twice, and this area is completely left. So their solution is completely wrong, and hence their options will also be correct. R is correct. Okay, 197 is the correct option. Is the correct answer. Yes. Let's move ahead. Now comes the centroid of a triangle. So if there is any triangle and you have projected, you have constructed the median on all the edges, and those mediums, all three medians, come to intersect at a point, and that point will be known as centroid of that triangle. Let's go by the definition. The centroid of a triangle is the point of intersection of its medians. The centroid divides the medians in the ratio of 2:1. Let me clarify. Let me draw the medians. These are the medians. As you can see, let's say A, B, C. As you can see that, let's call this as D point. So in AD, let's call this as G, because G is commonly used for centroid. Let's call this as Z. So here AG by GD will be following a ratio of 2:1. And that's the same with all the medians. Let's name this point as E. Let's name this point as F. So GP is to EG will also be following the same ratio. CG is to GF, not your girlfriend, will be also following same ratio, 2:1. Okay. Centroid divides the medians in the ratio 2:1. Vertex is to base. Vertex is to base. 1.2. Okay. So we have the formula for finding the centroid of a triangle, and that is very simple. You have to sum all the abscissas of the coordinate of the given vertices of the given triangle. X1 plus x2 plus x3 divided by 3 will be the x coordinate for the centroid. And for finding out the y coordinate of the centroid, just simply add y1, y2, y3 and divide it by 3. That will be the centroid. Please read this for a second and ask if there is any doubt. Okay, let's solve a question. The vertices of a coordinate of triangles. 3 minus 5. No, actually, two only vertices are given. One vertex is not given, and centroid is given. We have to find out the coordinate of the third vertex. Okay, simple. So we know that 2 will be equal to x1 plus x2 on 3. So x1 is 3 plus minus of 7 is the remaining coordinate divided by 3. 2 into 3 is 6. 3 minus 7 becomes minus 4 plus x3. 6 plus 4 is equals to x3. This becomes. Discussing about the y, minus y should be x1, sorry, y1 plus y2 plus y3 divided by 3. So y1 is minus 5 minus 1 plus y3 divided by 3. 3 into minus 1 minus 3 is equals to minus 6 plus y3. Bringing the minus 6 on the left hand side, 6 minus 3 is equals to y3. This becomes 3 is equals to y3. So the centroid comes out as plus 10 and plus 3, which is not matching with any of our option. First, let's recheck. Otherwise, the correct answer can be D also. Okay. So minus 5. Okay, that is 4. Yeah, that is 4. That is 4. And plus 4. Okay, minus 3 and minus 5 plus 4 becomes minus of 1. Minus 3 plus 1 becomes minus 3 and plus 1 becomes minus of 2. So the correct option will be 10 minus 2. Option number B is an Android. Let's check. Yes, precisely correct. Reread. Okay, let's move at chapter khatam. Prices. First point, circumcenter of the right angle triangle ABC is at A is B plus C divided by 2. Circumcenter is what? We have discussed about in center and circumcenter earlier. So circumcenter will be given by B plus C divided by 2. Orthocenter for the right angle triangle ABC. Right angle at A is A. So any right angle triangle. So its orthocenter will be existing on the right angle vertex as well. X-axis divides the line segment x1, y1, x2, y2 in the ratio y is to 1. and y-axis divides the line segment in the ratio of minus of x1 is to minus of x2. Okay, so here we are discussing about x-axis and y-axis dividing the line segments. So when axis divides any line segment, so which point will be there? So the y coordinate will be 0 and there will be some coordinate x. And when y-axis will be dividing any line segment, then the coordinate for x-axis will be 0 and there will be some y coordinate. And the ratios are given. This is like the direct result. Let's discuss it. Do I know it's an explanation? So there are points x1, y1, x2, y2. There is a point, there's actually an axis, complete axis. Let's call this axis as y. So on y-axis, we are very sure that x coordinate will be 0 and there will be some point y. Now what we are discussing is, we are finding out m1 and m2. So 0 is going to be equal to as m1 x2 plus m2 x1 divided by m1 plus m2. Cross multiplying, it makes it as 0 is equals to m1 x2 plus m2 x1. Let's bring m1 x2 to the left hand side. Now we had to find out m1 is to m2 now. So let's bring m2 on the right. Let's bring the minus x2 on the right hand side. Okay, let's do it on the next page. Okay, so where were we? Yeah, m1, bring the m2 onto the left hand side and bring the x2 and the negative sign on the right hand side. So our ratio has become minus of x1 is to x2 when y-axis was dividing the line segment. So it is very simple. X1 and x2 are the points here. Minus of x1 is to x2. This is the ratio. This is what the point is saying. This point is saying. Similarly, let's discuss about if there are two points A and B, x1, y1, and x2, y2. The line segment is getting intercepted by, let's say, x-axis. Let's call this axis as x-axis. On x-axis, we know there will be some point of x, but 0 y coordinate. There is some ratio m1 is to m2. So let's rely on the 0 coordinate because we are sure about that. So 0 will be m1 into y2 plus m2 to y divided by m1 plus m2. On cross multiplying m1 plus m2 into 0, that becomes 0. It's equals to m1 y2 m2 y. Simplifying it, so this will give us as minus m2 y1 equals to m1 y2. Bringing m2 to the right hand side and y2 to the left hand side. So m1 is to m2 becomes minus of y1 is to minus of y2. Now the key point to remember here, when x-axis will be dividing the line segment, then the ratio will be in terms of y. When y-axis is dividing the line segment, then the ratio is going to be in the terms of x, which will be minus of x1 is to x2. And when x-axis is dividing the line segment, then the ratio is going to be in the y terms, and which will be minus of y1 is to y2. I hope that is clear. Continuing our discussion. If ABC is a parallelogram, then D is equals to A minus B plus C. I'm not sure about what they have written as D. It should be the vertices they must be talking about. Yes, right. I've got the confirmation. They're talking about the vertices. Good evening, Yalini. Okay. So here D, E, F are the midpoints of the sides B, C, C, A, and E, B. So I have to explain this point. Midpoint. There are only 2 points A and B. And if there is a midpoint, the coordinate of X and Y is X1, Y1. Coordinate of B is X2, Y2. For midpoints, let's say this is the midpoint. We are very sure of one thing, that the midpoint is going to divide it in two equal parts. So AM is going to be MB. If AM is equals to MB, let me write it. AM divided by MB is going to become 1, which can be written as 1:1. So the ratio for midpoint is 1:1. Let's now find out the vertex of the midpoint. So x m1 into x2 plus m2 into x1 divided by m1 plus m2. That will give us x1 plus x2. I'm writing x1 first, just for the convenience of understanding. Similarly, y is m1 into y2 plus m2 into y1 divided by 1 plus 1. So y1 plus y2. So it's very simple to understand. The coordinate for midpoint will be x1 plus x2 divided by 2 and y1 plus y2 divided by. This reminds me of the coordinate of centroid, which are x1 plus x2 plus x3 divided by 3. And the ordinate for centroid of a triangle are y1 plus y2 plus y3 divided by 3. This time here midpoint x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now you will be able to better understand what this point is meant to say. DEF are the midpoints of sides BC, CA, and AB in the triangle ABC. So the point A is equals to E plus F minus of D is equals to A. First, let's understand this thing. D is equals to B plus C. 2D is equals to B plus C. Okay. And also 2D is equals to, 2E, because E is a midpoint of CA. 2f is equals to, multiple here, 2f is equals to a plus b. Now, what they have written is a plus d is equals to e plus f. Simply adding both of these equations, this will become 2e plus f is equals to 2 into a, 2a plus b plus c. B plus c is simply using third equation. B plus c is 2d. Cancelling 2. This gives us e plus f is equals to a plus d. Which can be written further as a is equals to e plus f minus of t. This is what they are trying to say in the first one. That's how this comes out. And b point can be given as f plus d minus of e. So it will be better if I draw a diagram here. We'll be able to clearly remember. There was a triangle. Its vertices were given A, B, C, and their midpoints. D was the midpoint of BC, and E was the midpoint of AC, and F was the midpoint of AB. Now, what it is trying to say that, let me take a different color. What it is trying to say that A can be written as the sum of E and F minus D. So it's easy to learn the formula from this diagram because it's logical here that E and F are close. So it's sum minus the D. Same pattern follows for C also. The sum of E and D, sum of E and D minus F. Right. So this is how we can develop that. This diagram will help you clearly remember, but just remember one thing, the midpoints that are nearer, their sum will be considered and subtracted by the midpoint that is opposite. So this is how we can represent and find out the vertices of a triangle if three midpoints are given. E, F, D, all are midpoints. Give me 2 minutes. Yes, so continuing the next point. If D, E, F are the midpoints of side B, C, C, A, and AB of a triangle ABC, then the centroid of the triangle ABC is the centroid of triangle DEF. Okay, so what they are saying that the centroid of triangle ABC that will be formed by drawing medians from A to D, C to F, and B to E. This median G will be the median of also the triangle EEF, sorry, EDF. The centroid for the triangle EDF will coincide with the point G, which is the centroid of triangle ABC. Simple. Is there any difficulty in understanding this?
No, sir.
Yeah. Talking about the next point, which is very, very important. The orthocenter, centroid, and circumcenter of a triangle are collinear. They are collinear, they exist on a straight line. And the centroid, which is in the middle of these 2 points, will divide the line segment joining orthocenter and circumcenter in the ratio of 2:1. First comes the orthocenter. There's a point. Orthocenter, centroid, and circumcenter. 2:1. So OG is to GC. It's 2:1. That's very important. Next point is the circumcenter of a right angle triangle is the midpoint of hypotenuse. And the orthocenter of the right angle triangle is the vertex that is having 90 degrees of angle. So the circumcenter will be here on the middle point of the hypotenuse. Going to the next point, in an equilateral triangle, orthocenter, centroid, circumcenter, in center, all these 4 points will coincide. Okay. In an equilateral triangle, orthocenter, centroid, circumcenter, in center, these all 4 points will coincide, will exist on the same point. A triangle will be isosceles if any two of its medians are equal. What are medians? Here you can see in this triangle AD and CF are medians, BE are medians. If any two medians are equal, so then the triangle will be isosceles. Triangle having two equal sides is an isosceles triangle. Next point is area of n-sided regular polygon is 1/4 pi a square of cot of pi by n. N is number of sides of a regular polygon and a is the length of the side. Let's find out for the area for the equilateral triangle. In equilateral triangle, how many sides are there?
Three sides which are equal.
Yes. So the formula becomes 1/4 pi a square into cot pi by 3. Cot pi by 3 is cot 60 degrees, which is 1/√3. Okay. So 1/4 into √3 into pi a square. Formula becomes pi a square divided by 4√3 for an equilateral triangle. But we need not to consider this formula because we already know there is a formula √3 a square by 4. Coming to the next, area of cyclic quadrilateral. Yes, this is important. It's important. Area of cyclic quadrilateral in which A, B, C, D are the lengths, are the sides of the cyclic quadrilateral. What is a cyclic quadrilateral? Can anyone tell me?
Where
Yes,
where
right.
a quadrilateral is enclosed by a circle on all its.
Yeah, yeah, very right. So all 4 points are existing on the circumference of the circle. Then the quadrilateral will be known as cyclic quadrilateral. And ABCD are the length of the sides here. Next point is in an isosceles triangle, centroid also center in center, circumcenter lie on the same line. So for equilateral triangle and isosceles triangle, this fact is true. Is this point clear? Are all these points clear? Any doubts?
Yes, sir.
Clear. So let's do an important discussion. Which is of orthocenter, like all these centers basically. We have already discussed about centroid, right? I'm just now going to give an idea of circumcenter. So let's use AI here. First, let's discuss what is a circumcenter. What is a circumcenter? First, defining what is a circumcircle. We have talked about it earlier also. So, circumcircle. Wait a minute. A circumcircle is just like a circle. Minute over. Just beginning. Anyways, leave the pen. Any circle on which there are three vertices of any triangle. That circle is known as a circumcircle, circumscribing a triangle. And the center circle will be known as a circumcenter. Circumcenter. So the circumcenter of a triangle is the point where the perpendicular bisectors of the sides of the triangle will intersect. This is the condition. It is equidistant from all three vertices of the triangle. Why? Why equidistance? Because it is the center of the circle and those three vertices will be lying on the circumference. So the distance will be of radius. This point is the center of the circumcircle, the circle that passes through all three vertices of the triangle. That is the circumcenter. Is that clear?
Yes, sir.
Next point comes in center. So the point in center is the like the triangle this time is outside and the center is inside. Sorry, the circle is inside the triangle. Okay. Now the center of the circle will be known as in center and this circle will be known as in circle. So the in center is the point where the angle bisectors of the triangle intersect. This is a condition. Okay. These are conditions that the angle bisectors of the triangle will be intersecting there. And that will be known as in center. It is equidistant from all three sides of the triangle. All three sides, not vertices, bro. Vertices say equidistance hoga means there was a radius. This time it is equidistance from the sides, means the perpendicular distance between the sides and the center of the circle. This point is the center of the incircle, the circle that is tangent to all three sides of the triangle from within. So this is a circle and the triangle is outside. Somewhat like this, touching here, here. And the angle bisectors will intersect at the center of the circle. Is in center clear? So repeat.
Could you repeat it, sir?
Yes, sure. I hope my pen works well. Okay, yes, it's working well. So there's a triangle. And inside the triangle, there exists a circle touching the sides of the triangle. So that is, this circle will be known as incircle. And the center of this circle is known as incenter. What is all written here are the properties of this incenter. So the incenter is the point where the angle bisectors of the triangle intersect. Angle bisector means if this is an angle, let's say 60 degrees. So there, there is an dotted line if I draw it, and this will form a 30 degrees angle. Like this will bisect the 60 degree in equal parts, 30 degrees. This line, dotted line, is angle bisector. Is this point clear?
Yes, sir.
Yeah. The angle bisector for this vertex, the angle bisector for this vertex, these all will intersect on the incenter. That is the first property. The second property says that, as you know, in a circle, the center is equidistant from all the points from the circle circumference, right? So here, the point where it is touching, these are all three are radius of the incircle, R, and R. And what is actually this? This is the distance between the side and the point. If there's any line and there's a point, so the distance we calculate is a perpendicular distance. So similarly, here this is a circle, and this is the side that the circle is touching on the one side. So the distance, this is radius, and this will be the same for other sides as well. That is why it is saying that it is equidistance. The incenter is equidistance from all three sides of the triangle. Is this point clear? Should I repeat?
No, sir. Clear, sir.
Clear. Okay, then let's move ahead to the next point. This point is the center of the incircle, as we have talked about earlier. The circle that is tangent to all three sides of the triangle means if there is a circle and if there is a line that is touching on only one point, so we call this line as tangent. And here it is happening with the sides of the triangle. That's why it is mentioned that the sides of the triangle are acting as the tangents. Is this point clear?
Yes, sir.
Great. So let's now move ahead to the next point, orthocenter. The orthocenter is the point where the altitudes or the extension of altitudes of a triangle intersect. If there is a triangle, and I have drawn an altitude here. Altitude means 90 degree altitude here. So where these all three altitudes intersect, that will be simply known as orthocenter. It do not have to do anything with any circle. It is just this point where altitudes intersect. Altitudes are the perpendicular lines drawn from each vertex to the opposite side, or the line containing the opposites. So this was the vertex A, and I had drawn a vertex on this opposite side. Is this point clear?
Yes, sir.
X circle. It is simple. The means, like, let's say there's a triangle here, and if we draw a circle touching this side only once, only once, only once. These are X circles basically. The X circle of a triangle is a circle that lies outside the triangle and is tangent to it, one of its side. The extensions are of the other two sides. The extensions of the other two sides. Basically, if you extend this also, then they will be also tangent this point. If you extend these points, So I have not like been able to make a perfect drawing. In the perfect drawing, let me show you that perfect drawing. First, let's cover other points. A triangle has three x circles, as mentioned, associated with one of its vertices. The center of an x circle is called the x center, and it is the point where the internal bisector of one angle and the external bisector of other two angles meet. What do you mean by internal bisector? This is the point in the internal bisector, and the external bisector somewhat here. Okay, we'll discuss these points. Let me show you the image. Whose class is next?
It's a science class, sir.
Okay. Is my screen visible? What is visible?
Co-pilot, sir.
See here. This is the X center. The side is tangent to the circle, and the extension of other sides are tangent to the circle as well. That's what make it as an X circle. Is this point clear? What is tangent? A tangent is a straight line touching the circle at only one point. Is this point clear or not?
Yeah, clear, sir.
Yes, so that concludes our chapter. Are there any other questions?
No, sir.
Okay. Thank you, Jane. Good
Thank
night.
you. Jai Hind, sir.